Hi all, welcome back to another lecture of DBMS, and in this lecture we are going to learn about query processing. So from how query starts processing, and we'll learn about whole flow, like how query parts, then how the query is being translated to the from human language to the machine language, and then how query actually execute inside the engine. So this video is going to be interesting. So let's start with the very first lecture, with the very first topic of this lecture. So first topic is query processing. So what exactly a query processing means? So it is a series of steps of a database management system, and that takes to retrieve data from database in response to a user query. So query processing are the steps to be followed by the data management system so that it can retrieve data as per the query requested by the user. Okay, so what all processes it includes? The process involves translating high-level SQL queries into a series of actions that the database can execute efficiently. Okay, so this process involves the translating of the high-level query into the language which the database management system can execute, such as reading data from tables, joining records, filtering rows, and sorting results. For all these, whatever the high SQL level language query has been written, it will get transferred into the language which the database can understand and execute properly. So the second point is the goal of a query processing is to minimize the time. So basically, we want the execution latency to be less, the time to give the response back for the query should be less, and also the resources need to execute a query. So number of resources, the memory, the storage it requires to execute the query should also be less, and that is why the query processing actually needs to be done by taking all these points to be in the mind. So the very first, let's see the proper flow of the query processing. The very first process is parser and translator. So basically, query parsing and translation basically includes that the query to check for syntax correctness. So if the user have written some query, and it might happen that there might be some syntax error. So this is the task of query parser and translator to check if there is any syntax or error in the query, and if any correctness or translation required, right? And this step ensures that the query is syntactically valid and can be further processed. Next step is query optimizer, and the task of query optimizer is to basically optimize the query so that it can execute the query within minimum time by taking the minimum resource. So the query optimizer evaluates different execution plans and selects the most efficient way. So optimizer actually executes so many plans you can say. Okay, let's suppose there we want to apply joins, okay, and we can apply joins in multiple ways by selecting first let's suppose person table, and later on customer table and order table, or if order table first, then customer table and person table, and so on. So this query optimizer actually performs all the different ways for the execution, and then selects the most optimized one which we can actually apply. Okay, so the most efficient way to execute the query and minimizing the resource usage and execution time also. So this is a task of the query optimizer to minimize the time and the resource which needs to be required for the query execution. Next is query evaluation engine. So once the syntax error validation has been done by the query parsing now or the translator, second, the query already been optimized so that it will take minimum time and minimum resource. After all this, the evaluation engine comes in picture, and this is responsible for executing and optimizing the query, and it processes the internal query representation and interacts with the actual database to retrieve or modify the data. So this engine, the evaluation engine, the task of evaluation engine is to basically get the optimized query and then connect with and interact with the database to retrieve or either modify the data. Okay, so let's learn about each process steps of the flow in depth one by one. So first is query parsing. So it is the first step in the query processing flow where DBMS checks the SQL query for any syntax error and ensures it follows database grammar's rule. So basically, parser is basically to check if there is any syntax error in the SQL query or not, right? So during parsing, the DBMS generates a parse tree or syntax tree. How it actually checks? So it generates a parse tree or syntax tree that represents the structure of the query. Okay. So parse tree and syntax tree is a way to represent whatever query you have written. So it will be formed in a structural way. And now if any part of the query does not follow the syntax route, so once after the structure has been created, and now we will check every part by part, and if any of the part does not follow any SQL syntax rule, then the error will be returned, and then the query cannot process further, like cannot go in another steps of the flow. So let's see the first statement. So we are selecting the train name from train table where train ID equal to 101. So you know the equal to the result gives either true or false, right? So here the query itself is wrong. So what can be the correct query for this? That instead of equal to, we have to use single equal to, right? So in this case, as it consists error, so the query will not get processed further. So that's what the task of query parsing means. Second comes the query translation. So this after a query is being successfully checked and parsed and translated that yes, it does not contain any syntactical error, then it is then translated into an intermediate representation. Intermediate representation means that it will be converted in the relational algebra. So this is the select query which we can understand, right? But if we will talk about the database engine, that it won't understand this select and simple basically query which we write, right? So the translation, what it will do, it will convert this simple basic SQL query into this relational algebra query. How we actually what each symbol like sigma and pi and all symbols means, we'll be learning in our upcoming lectures for sure. But as of now, just understand this part, that it will convert the basic SQL query in relational algebra query. And these process involves converting SQL query like this, whatever we apply like join, filter and projection, into corresponding relational algebra operations, and this would be translated into a relational algebra operation like how. So if you can see this pi sigma, right? So basically pi means that if the source is Delhi, right? So it basically selects all the rows having source Delhi, and pi means projection. So it will give you the result of having train name whose source is Delhi. So that's how we convert this. After conversion, this is how relational algebra query will look like, and that is the task of query translator to do this. Okay. Now next last step comes is, once the query has been checked and syntactically checked, and also it has been converted in the relational algebra, basically the most optimized way. Now this is the task, the execution task will be done by the execution engine, and it is responsible for taking the optimized query plan and executing it against the database. So the task of execution engine is to basically check the most optimized query for the execution, and now it will execute the query against the database and modify or retrieve the data according to the requested query. So it performs actual operations such as reading table, performing joins and applying filters. So before this, this much step, whatever the 2 steps we have learned, those steps were actually working on the query itself. But this in this step, the query will work, the actual query will work, like all the filters, all the selections of data from the database will be done here in this case. So this is what the actual operations, reading, performing joins, applying filter, returning results to the user will come into picture. And the execution engine actually interacts with the components like storage manager, retrieve and manipulate the necessary data. So this is, let's suppose this is our query and we have train name and passenger. We want these 2 columns in our resultant table, right? And we are selecting from trains table and joining it with the bookings table. On what condition? Having the train ID should be same in both the tables, and along with that, the train's source should be Delhi. Okay. So now the execution, how the execution engine will perform it. First, it will access the train table and retrieve all the rows having the source Delhi. Why it is so? Because if it will not do that, then from trains table it will select, let's suppose we have 1 million of rows from trains table and 1 million of rows from bookings table. So it will parse all the rows from trains table, right? So that is why we want to select only those rows which is having source Delhi and then load it, right? So it might happen that 1 million of rows in booking in trains table have only, let's suppose, 5,000 records having source Delhi, right? So basically we are, instead of loading 1 million of rows, which will actually, instead of optimizing it, it will use more data, more resource, and takes more time to execute. So it's better to select first, load only those rows having the source as Delhi. Now after this, do the join operation, and then we'll check if train ID is there in both the tables or not. That is what first step is: access the trains table and retrieve the rows where source is Delhi. First step. Now second, after these, join these rows with the corresponding rows in the bookings table on the train ID. So now the train ID, once we have selected all the train rows having source Delhi, so we have train table in hand having 5k records, let's suppose, instead of 1 million. Now this we will try to join with bookings on the condition that their ID should be same, and at last we will return train name and passenger name from that table, like resultant table, and we'll give the table having the two columns, train name and passenger, as the result of the matching records. So that is how all the actual steps of the SQL query is being performed by the execution engine, by taking care of the point in mind that the execution time should be less and the resource usage should also be less. So that was all about the query processing methods in the flow, and what we have learned about the three different methods of the flow. So first step is basically in the query processing was that first we were checking the query parsing, and where we were checking if there is any syntactical error or not. If there is any error, then we won't be proceeding further, or if there is not, then we'll be proceeding further. Then the second step was translation, where the actual SQL query was translated into the relational algebra query, which we will be learning in our upcoming slides, how we actually convert with the relational algebra query. And next comes is the execution engine, where we have learned how the actual query is in the real world, how it is interacting with the database and the resource management systems and all, and retrieve the data and manipulate or modify the data according to the requested query. So that was all about the whole lecture. I hope you learned and remember all the concepts which we have discussed in the today's lecture. Now let's meet in another lecture with some more interesting and important topics. So then keep learning, take care of yourself and your family too.